For this emulation, we're going to look at draft, shell, fillet, and chamfer. We have a part today that we're going to start with a circular tube, so a cylinder that is a diameter of 100. We're going to pad that a distance of 50, and these are in millimeters. And then from there, we're going to draft the cylinder. We're going to use the outer edge as the face to draft, and then the neutral face is going to be, in this case, we're going to make it the bottom one because we want it to be the same 50 around the arc that is on the base. So we're going to just rotate this around so that we can grab that neutral face as the bottom base. We're going to use a draft angle of 20. Make sure we flip that direction because it looks like right now it's going outward from the top, but we want it to actually go inward. So we'll use that directional arrow at the base there to flip the direction. From here, I want to create the base shape that is the rectangle with the curved arc on the side. So we're just going to start with a rectangle and make the points of the circle tangent to the rectangle and set those values to be 100 square. Both the length and the diameter there will be 100. But once we make the cylinder tangent to the square, then we don't have to define the 100 again there because it's already implied from the tangency. From there, we need to create the arc. We could use a circle and then cut away half of it, but here I'm going to use the arc center coincident to the origin there, and then create the arc to go from that top corner to the bottom. Looks like I missed the center being coincident there. I'm a little bit off with my placement, so I'm going to grab that center point, go ahead and make it coincident to that vertical axis. Now that looks right. So from here, what I'm going to do is use the quick trim tool to remove that center line segment so that we have one closed circular loop. And then try and figure out why we aren't fully defined. Looks like my point was just ever so slightly disconnected, and I managed to connect those back together and make them coincident. So from here, I will exit the sketch, pad the feature, a distance of 25. And then from here, I want to go ahead and add a couple of modifying features. So first we'll add a fillet to both of the edges that are sharp points there. We'll do them together so that they create one feature fillet. We will set that to be a radius of 20. And then we'll add a face-to-face fillet between the base there. You could do it as an edge fillet, but this makes it a little bit easier to just grab the two faces that I'm doing a fillet between, and that fillet is going to be a radius of 5. From here, I'm going to go ahead and shell my feature. So I'll rotate around to grab, in this point, I do want the top to go all the way through as well. So I'll shell from the bottom, but then also select that top face of the peak of that cylinder to remove material from there as well. By selecting both of those faces together, I can do the shell in one move that is one solid, typical dimension all the way through, but leaves gaps opening on both sides. So here that is 10 millimeters thick, and it's an internal thickness. I could have done an external thickness. That would mess up my dimensions from what I want them to be. So here I'm going to add 2 holes concentric to my fillets. They're going to be a diameter of 10. And they are going to go through all. And in this case, it's only going to go through 10 millimeters worth of material because they are far enough from the edge that they're not going to go through the material. Since it's already shelled out, it's only 10 millimeters thick at that area. The last thing I need to do is add a chamfer, and I want to add that inside the lip of the internal cylinder. So I'm going to grab that edge, make it a 45-degree angle. And then my length is going to be 5. So it'll go half the distance of my thickness. And that is my completed part.